there. So for today we will look into work. Okay. The main definition of work is that we can define as a scalar or dot product between force and displacement of a body. Okay. So by an equation we will get work will be equivalent to F dot S. Okay. So by expanding dot product we will end up with Fs cos theta. Okay. Where cos will be the magnitude. Okay. S displacement experienced by the body, and theta will be the angle between force and displacement. So the work done is a scalar quantity, okay, and then the SI unit will be joule. Okay. 1 joule is defined as the work done by a force of 1 Newton, which results in a displacement of 1 meter in the direction of the force. So that means the displacement and force should be in the same direction. Okay, example 2. You have a box, okay, mass given as 20 kg, moves up a rough plane which is inclined to the horizontal at 25 degrees. Okay. It is pulled by a horizontal force F of magnitude 250 Newton. The coefficient of kinetic friction between the box and the plane is given as 0.3. Okay, for question 8. If the box travels 3.8 meter along the plane, they wanted to determine the work done on the box by force F, the work done on the box by the gravitational force, the work done on the box by the reaction force, the work done on the box by the frictional force, and then finally the total work done on the box. Okay, and for question B, the speed of the box is 0 at the bottom of the plane, and then they wanted to calculate its speed when it has traveled 3.8 meters. Okay, so for solution, first thing, derive all the information given. So we have the value of mass, force, coefficient, and also displacement. So based on the description, what we can do is that draw a free body diagram. Okay. So what we do is that we redefine the axis, okay, where y-axis will be perpendicular with the plane and x-axis will be parallel with the plane. Okay, direction of the acceleration, and then the displacement from the initial to the final position, which will be 3.8 meter. Okay, acting force, so which can be resolved into x and y component. Angle will be 25, and then we will have normal force. Okay, weight, which will be acting downward toward the center of gravity. Okay, distribution of weight in x component and distribution of weight in y component. Okay, since we have coefficient, that means we will have friction acting between the surface of the object. Okay, consider work done along inclined plane. Thus, okay, for work done by the component F, okay, so that means we resolve into Fx, then multiply with the angle. So since the movement and the direction of the x component is at same direction, the angle will be 0. That means the angle between Fx and S will be 0. Okay, which will end up with work done by force by the x component. Okay, and then work done by gravity. So weight acting downward, okay, which will be the x component. So angle will be 180. So this one we will get a negative work done, okay, because the angle is 180. And then work done by normal force. Okay, so this one angle will be 90. Okay, so therefore there will be 0 work done. And then work done by friction. Okay, since the angle is 180, also we will end up with a negative value. Okay, which will be equivalent to negative 323 joule. Okay, so for the net work done or total work done, what you need to do is that just add up all the values, okay, which will end up with 223 joule. Okay, since the initial velocity is given 0, okay, by using the equation of work for the net force, okay, what we can do is that we can calculate the acceleration. Okay, so once you have the value of the acceleration, you can use equation of linear motion. Okay, initial velocity is 0. Okay, we have the value of displacement and then we have the value of acceleration. Therefore, you can calculate the final velocity. Okay, that's all for example 2. Okay, for example 3. Example 3, you have a F versus S. Okay, force times displacement graph. Okay, so if you have a force times displacement graph, what we can do is that we can calculate the amount of work done, which will be equivalent to the area under graph. So this one, we have a horizontal force applied to a 2 kg radio control car and it moves along a straight track. The force varies with the displacement of the car, as shown in figure. We want you to calculate the work done by the force when the car moves from 0 to 7 meters. Okay, straightforward question. Just determine the area under graph. Okay, which will end up with 18 joule. Okay, that's all.